We're starting the second half of this course where we're taking the ideas from geometry, but we're learning how to apply them in a different context. We're going to be looking specifically at how the angles and the sides of a triangle are related to each other. And we'll start with a right triangle, and then we'll move into triangles that don't have right angles because not every triangle has a right angle. But when we do have a right angle, then we're going to have the three angles of the triangle. Angles are usually given in capital letters. And then we'll have the three sides of the triangle. Now, typically they are labeled with lowercase letters. And if you look across from an angle, you're going to get corresponding letters. So angle A is across from side A, angle B is across from side B, and angle C is across from side C. Now, when we have given a particular angle of reference, whether it's angle A or angle B, let's say, for example, I wanted angle A as my reference angle. Then the side that's right next to it is the adjacent side. Okay, adjacent means next to, so that would be our adjacent side, the side that's right next to it. And then the opposite side, so this is adjacent side to angle A, the opposite side would be opposite. So this is the opposite side to angle A. And then the hypotenuse is always the hypotenuse. The hypotenuse is always across from the 90-degree angle, and in a right triangle, it's always the longest side. Now, this all changes if our reference angle is angle B. If we were doing angle B, then the side opposite would now be over here, and the side adjacent would be the side right next to it. So it all depends on your angle of reference, which side is opposite and which side is adjacent, but opposite is always the side not touching that angle, and adjacent is always the side that is touching that angle. So we have these 6 trig ratios that help us recognize the relationship between the sides and how that relates to an angle. So we have the sine, and when we talk about the sine of an angle, it's just a calculation that we do on an angle, and it is found by taking the length of the opposite side and dividing by the length of the hypotenuse. So that ratio is described as the sine of an angle. Then your cosine is the ratio where you've taken the adjacent side over the hypotenuse. And then tangent is where you've taken the opposite side over the adjacent side. Now, many of you might remember from high school where you had SOHCAHTOA. Maybe that sounds familiar. And it's because you can simplify this as sine is opposite over hypotenuse, SOH, cosine is adjacent over hypotenuse, CAH, and tangent is opposite over adjacent, TOA. Now, we also have 3 additional ratios that you may not have ever encountered before. The cotangent is just the reciprocal, or you flip the fraction of tangent, where you've taken the adjacent side over the opposite side. The secant is the reciprocal of the cosine, and that's where you've taken the hypotenuse over the adjacent. You just flip that over. And then cosecant is the reciprocal of sine, where you've taken the hypotenuse over the opposite. So we're going to use these 6 ratios to help us understand how our triangles, how the angles and the sides are going to basically give us the other measurements by knowing what these ratios are. So how do we do this? So let's take, for example, angle A. So if we have angle A, then the opposite side is that 12, and the adjacent side is the side that's 5, and the hypotenuse for all of these will be 13. So if I wanted to define the sine of angle A, I'm going to make the ratio of the opposite side over the hypotenuse, and it's simply going to be 12 over 13. Now, cosine is the adjacent over hypotenuse, And so the adjacent side is 5, the hypotenuse is 13. So the cosine of angle A equals 5 over 13. Okay, that's a function just like if we were squaring or taking the square root. It's just an operation that we do on the angle A, and it's going to be defined based on the lengths of the sides. Tangent you do by opposite over adjacent. So here it would be 12 over 5. Now cotangent is adjacent over opposite. You do the flip of tangent, 5 over 12. Secant is the hypotenuse over adjacent, or the flip of cosine. And cosecant is the flip of sine, or you could think that as hypotenuse over opposite. Now, let's go back to our box up here. Notice that I used simplified letters for example 1. Sometimes we use just 3 letters, and the 3 letters are as what I'm writing right here. So when you see SIN, that's a sine, and say sine. When you see COS, you would say cosine. When you see TAN, you would say tangent, and you would know that that's just the abbreviation for these different angles. All right, now let's go back to example 1, and this time I want us to use our reference angle as angle B. So now our adjacent side is the length 12, and our opposite is the length 5. And so the sine of B is going to be opposite over hypotenuse. The cosine is going to be the adjacent, which is 12 over the hypotenuse, and the tangent is going to be 5 over 12. Then cotangent would be the adjacent over the adjacent over the opposite. Secant would be the hypotenuse over the adjacent, and cosecant would be the hypotenuse over the opposite. So all of these trig ratios are just defined as the ratio of 2 sides of a right triangle. That's all we're doing here. So let's also look at this example here. I want to find sine A and tangent B. So if I want to find sine A, then that's going to be the opposite over the adjacent. But the problem is, I don't know my opposite side right now. Right now it's just given A. But what kind of triangle is this? This is a right triangle. So we can use Pythagorean theorem first. And we can say leg squared plus the other leg squared equals the hypotenuse squared. And so we need to find 15 squared, it's 225. We need to find 17 squared, we get 289. And so we subtract 225, and then we take the square root, and so side A is actually 8. So these are right triangles, so if you're missing a side, just use Pythagorean theorem to find the length of that side. And now we can find sine A. It's going to be the opposite over the hypotenuse, which is 8 over 17. And then to find tangent B, well, now we're looking at a different angle. And when we do that, angle B here, adjacent is the side next to it, opposite is the side across. So opposite over adjacent would be 5 over 8. So it is absolutely essential that you always describe which angle you are taking the sine, cosine, or tangent, or any of the reciprocal functions of. If you just write SIN, that is incorrect. You cannot just have SIN on your paper. That doesn't make any sense. That's the same thing as having a square root with nothing under it. Okay, it doesn't mean anything. It doesn't make any sense. You must have an angle. Okay, whatever that angle is, it doesn't matter, but you have to have an angle when you're describing the sine, the cosine, and the tangent.